Let's take a look at another example. Let elementary matrix E equal to this matrix, and let matrix A equal this matrix. Let's find the product of E times A without explicitly multiplying matrices E and A. Okay? So the key here is that E isn't just any old matrix, it's an elementary matrix, which means it's equivalent to an elementary row operation. So if we can figure out what elementary row operation that E is equivalent to, we can apply that elementary row operation to matrix A, and that will give us a result equivalent to E times A. Okay? So let's start by figuring out what elementary row operation E is equivalent to. So we know we obtain an elementary matrix by applying one elementary row operation to the identity matrix. So let's start with the identity matrix, I3. Okay. And we want to apply some elementary row operation to get our elementary matrix 0, 1, 0, 1, 0, 0, 0, 0, 1. Okay. So how do we do that? What operation could we apply to go from here to here? Well, in this case, all that changes is that this row is now row 2, and what was our row 2 is now our row 1. So I'm just swapping the two rows. So if I want to find E times A, what I could do is I could take matrix A, 0, 5, 2, negative 2, negative 5, negative 1, and I could apply the same elementary row operation. So if I swap rows 1 and 2, row 1 is now 2, negative 2, row 2 is now 0, 5, row 3 stays the same. This is going to be equal to multiplying my elementary matrix by matrix A. Okay, let's confirm that actually. Let's actually do it. It says not to multiply them explicitly, but let's do it just to check our work. 0, 1, 0, 1, 0, 0, 0, 0, 1 is my elementary matrix E. Matrix A is 0, 5, 2, negative 2, negative 5, negative 1. And so I will get a 3 by 2 matrix when I'm done. Okay. And I'm going to take each row of matrix E, multiply it by each column of matrix A. Take the dot product, rather, of each column with matrix A. Okay, so if I take the dot products here, clearly I get 2. Let's continue in the first row. So first row of E, second column of A. I'll get negative 2, right? If I take the dot product. Let's go to the second column. Second column of E, first row of A. If I take the dot product of these, I will get 0 plus 0 plus 0 equals 0. Second row of E, second column of A, take the dot product, 5 plus 0 plus 0 equals 5. And finally, the last row of E with the first column of A, take the dot product of those, I'll get negative 5. Last column of E with the second column of A, if I take the dot product of those, I get negative 1. And so our answer check worked. This really does just swap the two rows of A. Row 1 and row 2 have been swapped from where they were before, right? Now row 2 is row 1 and row 1 is row 2. So the elementary matrix really does what we said it does.